This is the third block of topic 14. In this lesson, we're going to be looking at developing the distance formula as an application of the Pythagorean Theorem. So let's look at our problem 1. It says Aiden and Darlene have entered the Pythagorean Lake Endurance Trial. I'm sure that this exists, right? It says part of the competition requires them to travel from Geoville, which is on the south side of the lake. So we're going to go ahead and go to the south side of the lake and put a point there and label it as a Geoville. And they're traveling to Triples City, which is across the lake and due north of Geoville. So place a point due north on the other side of the lake and label that as Triple City. Aiden decides to ride his scooter from Geoville to Angle Point. Angle Point is a town which is 20 miles due east of Geoville. So if you'll extend out a section here from Geoville to a point that's due east, we're going to label that as Angle Point. And we know that that distance right there is 20 miles. And then he's going to continue on to Triple City. So I'm going to go ahead and connect that distance here to Angle Point. It says there's a direct route that runs in a straight line for 25 miles from Angle Point to Triple City. So we're going to label this distance right here as 25 miles. It says Aiden's scooter can go no faster than 35 miles per hour. Now, Darlene thinks she can beat Aiden to Triple City by taking a fishing boat, which averages 12 miles per hour, directly from Geoville to Triple City. So she's going across the lake. So since this was due east and this was due north, we know that this is a right angle right here. Now, we want to know who will get to Triple City first. Well, Aiden, we have all the information we need to know how long it's going to take him to get there. So remember, he's starting at Geoville, going 20 miles to Angle Point, and then 25 miles to Triple City. So he's going to go a total of 45 miles, and he is going at a rate of, we're going to say no faster than 35 miles per hour. We're going to say the whole time he's going 35 miles per hour, his fastest rate. Now remember, you should know this formula. Distance is equal to rate times time. So if we want to know how much time it's going to take him, we're going to take his distance and divide it by his rate. So we need to divide 45 by 35 to find his time, and his time is about 1.29, and it would be in hours since his rate is in miles per hour. So it's going to take him approximately 1.29 hours. Now, Darlene, we know her rate, but we need to find her distance, right? So we need to know that distance across the lake. Now, again, I've been really focusing on these Pythagorean triples to save you guys time. And remember, the most famous one is the 3, 4, 5. Well, the hypotenuse of 25 here and this leg of 20, I hope you recognize is an application of that triple. It's all of these that are multiplied by what number? It's multiplied by 5. 5 times 5 is 25. 4 times 5 is 20. So what's 3 times 5? 15. So that tells me this distance across the lake is 15 miles. So Darlene is going 15 miles at a rate of 12 miles per hour. So her time, again, is going to be the distance divided by the rate. So 15 divided by 12. And her time is 1.25 hours. So who is going to get there quickly, or the quickest? Of course it would be Darlene, right? So Darlene is the winner. She is going to get there fastest. Even though she was going slower, she's going a much shorter distance. And so she actually gets there sooner. All right, so let's look at number 2. We're going to label each side of this triangle with the expression that represents its length, and we have answer choices here. And so let's look at these vertical and horizontal distances first. So first of all, I want you to recognize that both of these points have the same y value. They are the same number of units up from the x-axis. Now, their x-coordinate, their horizontal distance, is not the same. So to find how much distance there is from point to point, we would look at the change in the x-coordinate. So we would use 8 minus 2 as how we would find that distance. And of course that would be 6 units, but for what we need it for, we're going to leave it as 8 minus 2. These 2 points have the same x. They both go 8 units to the right from the y-axis, but their y values are different because one is obviously higher than the other. So to find that vertical distance, we would focus on the y-coordinates change. And again, the higher number minus the lower number, since distance would always be a positive value. And so we would know that would be a distance of 8, but we're going to leave it as 11 minus 3. Now, using the Pythagorean Theorem, which we know is a squared plus b squared equals c squared, the a would be 8 minus 2. So we would have 8 minus 2 squared. The b would be the 11 minus 3. So we'd have 11 minus 3 squared. So to find the c, we know we have to undo the squaring. We would have to take the square root of each side. So hopefully you see that this c value right here is the square root of the 8 minus 2 squared plus the 11 minus 3 squared. Now we went through that with numbers so that we understand how to apply that generically with variables, because this is how the distance formula is created using the Pythagorean Theorem. So it's the same thing except we've taken the numbers away. We're going to use variables instead. So the first thing I want us to do is to be able to tell what the coordinates of this point is. So remember, since it's on the same horizontal line as this point, they have to have the same which coordinate? The same y, right? There's the same number of distance up, right? And that's the y value. So it has to have a y sub 1 as its y coordinate. Now these 2 points are on the same vertical segment, and so they have the same x coordinate. They're the same values to the right from the y-axis. So this point has to have the same x as that point, which is x sub 2. So this point is x sub 2, y sub 1. So now to find this distance, remember they have the same y value. The distance is the change in the x. Always the bigger one minus the smaller one. So we're going to write this as x sub 2 minus x sub 1. And here they have the same x, so the distance is the change in the y. So y sub 2 minus y sub 1. Again, if we were to use the Pythagorean Theorem, we would have this squared plus this squared equaling c squared. And we would have to take the square root to find c. So this distance right here would be the square root of x sub 2 minus x sub 1 squared, a squared, plus y sub 2 minus y sub 1, b squared. So that is the distance formula right there. To find the distance from these 2 points, since they are not a horizontal or vertical distance, we can just count distance in units. This is how we would find the distance between those 2 points. It's the square root of the change in change in x squared plus the change in y squared. So number 4 says write the formula for d, which represents the distance between any 2 points on a coordinate plane. And the distance formula is simply the square root of the change in x, which is subtraction, squared, plus the change in y, squared. That is the distance formula. And we can see how that was derived using the Pythagorean Theorem. So that's it for the lesson. I do want to point out a couple of things on your homework, the instructions. I've underlined several times throughout the homework that you're rounding to the nearest tenth when necessary. So I want to make sure that you understand again what it means when necessary. If you are finding a value and you get your answer as 1.25, that is what we call a terminating decimal. We do not need to round that one when the instruction says when necessary. Now, if it just said round to the nearest tenth, that means always round to the nearest tenth. But when the phrase when necessary is there, that means only when your decimal does not terminate. So since this one does, you would not round it. Now, if you get for your answer 1.01654, so on, and I'm rounding to the nearest tenth because this one is a non-terminating decimal, it's going on forever, the number in the tenths position is a 0, and next door is not high enough to make that 0 a 1. Do not just say your answer is 1. It is not just 1. Your answer would only be 1 if it literally was just 1. That's what you got as your answer. But we did not get 1 as our answer. So you would need to conclude the point 0 as your rounded answer. So 1.0 and 1 do not indicate the same answer. 1 means it was a terminating answer. It was just a 1. This means it rounded to 1. So we have the 0 in the tens position. So if it's a non-terminating decimal, make sure you have a number in the tenth spot, even if it has to be a 0. The other thing I want to point out is on number 9, when you're finding the distance between these 2 points using your distance formula, since these are fractions, it'll be really helpful if you know how to enter fractions in your calculator, and I don't mean just using the division key. You can use the alpha key on your calculator and then press the Y equals, the top left gray button. Alpha Y equals will allow you to enter fractions more easily. All right, good luck.